The next feature of an atom that we need to learn about is called the mass number. It's given the symbol capital A, and it is sometimes referred to as atomic mass, so watch out, those two words can be used interchangeably and they mean the same thing. There are other more advanced terms like molar mass and relative atomic mass. We won't go into that just now, maybe a bit later in the video. So, first thing you need to know, mass number is essentially the mass of your nucleus, if we talk in relative terms. If a neutron weighs 1, a proton also weighs 1, and an electron is very, very lightweight. It essentially doesn't really matter. So, write the expression down. The number of protons plus the number of neutrons equals your mass number. You need to have this memorized and use it all the time, especially when you're going to be asked how to draw an atom from scratch, or take information from the periodic table and have to deduce the rest of the information for yourself. I've got 3 little examples here we can go into if we look into the mass number. So I've got a diagram here of an atom on the right-hand side. You can see the electrons on the outside. Again, they're very lightweight. We don't care. We just look at how many protons and neutrons there are. And in this diagram, I can see I've got 1, 2, 3, 4, 5, 6 protons. So I got 6 protons plus the number of neutrons I have in here. So that's my black particles. 1, 2, 3, 4, 5, 6. 6 neutrons. That gives me a mass value of 12. I'm just going to use the pound or hashtag sign to represent the word number. Very simple. Now, just while I'm on this note, the blue and the black dots in the middle that I've used to denote protons and neutrons respectively, that is completely arbitrary, meaning that I've chosen blue to mean protons and I've chosen black to mean neutrons. That's not a hard and fast rule. If you got a red and a black pen, or if it depends on the textbook. So if you are using colors to represent your diagrams, make sure you also have a key or a legend so your teacher can tell which one of those colors means the protons and which one means the neutrons. The next diagram here half below, I've just taken a very basic slice out of the periodic table. Again, we've got sodium, and we have our favorite friend here, the 11, which is the atomic number, which tells us how many protons there are. So I know that sodium here has 11 protons. The other number you find in it, in this little section of the periodic table, is 23. That's usually much larger than the atomic number. And that's because this is your mass number. So I'm going to draw an arrow right over here. That is our mass number for sodium. What are we going to do with this information here? The most useful thing you can do is take the atomic number and the mass number and find the difference. If you find the difference between those two values, you essentially find how many neutrons there are in that atom. So just looking up at our expression above, I have the atomic number, which tells me the protons. I have the mass number. It's been told to me on the periodic table as well. I can do a simple difference of those two values, and it tells me how many neutrons that particular atom must have. So that means I've got 11 protons plus something gives me 23. So I can take 11 from both sides, and that gives me, let me see if I can do maths, 12 neutrons. So I've quickly just worked it out. You may need that information, especially if you are expected to be asked to draw an atom from scratch on a test, or you have to do a simple calculation on an exam. The next bit we're going to go into is I've got this bit here, carbon-14. I know it looks like a minus sign, but work with me here. Carbon-14. What is this about? This is to do with isotopes. Now, an isotope, if you remember from Year 9 science, it essentially, one element can have different variations where the neutrons can be more or less. Okay, so to be, let's say we're talking about nitrogen. Nitrogen is number 7 on the periodic table. That means all atoms of nitrogen must have 7 protons. Otherwise, it's not nitrogen. Now, the electrons can come and go. They can be exchanged or given away. So we can't depend on them to tell what kind of nitrogen atom it is. But the number of neutrons that an atom is born with can be more or less. Just in the same way as that in your family, you all share the same surname or last name. But some of you are bigger, shorter, heavier than others. The same idea for elements in the periodic table. Some of them have a family, so nitrogen has a family, and some of them are heavier or lighter than the others. And the way we differentiate those isotopes from each other is by their mass number, how heavy they are. Carbon has a family of 3. It has carbon 12, carbon 13, carbon 14, and each of those values, 12, 13, and 14, are the mass numbers respectively. So this is our notation for writing down isotopes. So we're talking about the specific isotope of carbon, which has 14 as a mass number. So sometimes this is drawn like this, where I've got a capital C, just like from the periodic table symbols, and a 14 written up in the upper left corner. So just be aware of that. So if you see carbon-14, it's talking about an isotope. If you've got hydrogen-3, that's also an isotope of hydrogen. Last example I have here in the corner, this is F. F is for fluorine, very reactive element. And we can see that we've got the number 9, that's the atomic number of protons. And the value below is a little bit different from what we had before. Can you see how it's got 18.998? Why is it a decimal number? That is the mass number, but why is it a decimal on this occasion? You will find in most periodic tables they are actually some sort of decimal answer, and that's because it is reflecting a weighted average of those isotopes. So I can tell straight away from that little digits there that fluorine has a family and different isotopes in it, and if we take an average of all of their weights, depending on how popular some are versus other popular ones, then we get an average value of 18.998. What are you going to do for most occasions, especially if your question asks you how many neutrons does a fluorine atom have, and you're looking at it, I can't find the difference between 9 and 18.998. What I got to do? What I suggest to you is I want you to round that mass number to the nearest whole number. Okay, the nearest whole number for that is going to be 19. So knowing that, the difference between 9 and 19 is obviously 10. Therefore, this thing must have 10 neutrons. With that said, we're going to go to the next topic, which is about the charge of atoms.